All right, at this time, we're going to bring this next guy up. This gentleman is somebody that I've known and worked with since 2000, so we've been together a little bit while. He's kind of the Bert to my Ernie, but Dave Bogema is somebody that is both personally and professionally means a lot to me. So I want to have Dave Bogema coming up and talk to us about the future of VI Grade's multi-attribute approach. Dave?
All right, so today we're going to talk about experimental simulation and especially multi-attribute simulation. So when you drive your car, you excite different frequencies and experience motion and vibration and sound all at the same time. Now, usually these characteristics are studied and engineered separately. They're usually development activities are carried out separately on separate prototypes or separate CAE models. But it's not just about how the car handles or rides or what it sounds like or what it feels like independently. It's all these things together. So ideally, you'd want to experience all those different aspects of the vehicle simultaneously while you're driving your virtual prototype. So ultimately, the goal is to make better design decisions faster with confidence, the confidence that those decisions are correct. So a little background. When we talk about simulating vehicle dynamics, sound, and vibration together, we need to define and understand the frequency ranges involved. So sound, or the noise part of NVH, generally covers the range from 20 to 20 kilohertz. Vibration typically covers the range from 5 to 150 hertz, and motion is generally considered 0 to 10 hertz, the overall movement of the vehicle. So sound and vibration and motion, they all interact and they affect our overall perception of the vehicle as we perceive it as human beings, especially in these overlap regions here. When we look at how to build a multi-attribute simulator to cover this full frequency range, it's useful to look at the various stages that comprise the overall experience. So we can look at handling, and handling is primarily the 3 degrees of freedom up to about 15 hertz. That's the overall behavior of the vehicle. And then we have ride, which is 6 degrees of freedom up to about 30 hertz. So overlapping these is the vibration that goes up to about 150 hertz. And on top of that is the sound that goes from about 20 to 20 kilohertz. So again, all these things overlap one another. Now we can look at what an ideal situation would be for a full spectrum multi-attribute simulator, combining ride and handling and sound and vibration. And we can look at the individual attribute of each, and we could build a simulator to simulate each one. And that's kind of what we've done in the past. So we can build a handling simulator or a ride simulator or a vibration simulator or a sound simulator. But what we really want to do is create a simulator that encompasses all these attributes at once. Again, all of these things feed into each other, and we want to create a virtual prototype that has all these attributes and frequency ranges together simultaneously. So the Compact FSS is the first real-time driver-in-the-loop simulator that actually accurately combines motion, vibration, and sound in a single simulator. So it starts with a carbon fiber chassis that's optimized to be light and stiff for accurate response. And the most notable feature is the legs. So these provide roll, pitch, and vertical motion to the simulator and accurately reproduce the motions, the overall motions of the vehicle while it's driving. So there's movers attached to the frame to give you fore-aft motion of the entire simulator. And for high frequency vibration, we have 3 shakers under the seat, giving us fore-aft, vertical, and lateral vibration to the seat base. And there's rubber mounts there to isolate that from the rest of the chassis. And then on the steering wheel, we have vertical and lateral vibration. Again, delivering that vibration directly to the driver at the driver touch points. Sound is provided through the headphones, through our NVH simulator software or SimSound. And all of this is powered by the AutoHawk real-time system to give us a complete, integrated, real-time motion, vibration, and sound experience. Now, one of the applications that this is ideal for is ride comfort, where motion and vibration and sound all combine into the overall perception and ride quality and comfort. This is sometimes also called vehicle refinement. The compact FSS lends itself well to this, as well as to seat comfort evaluations and tire evaluations, especially as they affect ride comfort and vehicle refinement. Of course, one of the primary intents of this is to be able to utilize various types of CAE simulation data to enable the experience of virtual prototypes and eliminate the need for physical hardware. So you may be wondering how all this operates, what kinds of models are used to provide the information to control this simulator. So here we're really combining two separate technologies into one. So for the motion, the ride, the handling, the low frequency vibration, we're using the standard VI grade software stack, including the VI Drive Sim, Car Real Time, and used in conjunction with the AutoHawk. For sound and vibration, we're using the NVH simulator software to provide the sound and vibration portions synchronized to the motion. And the visual environment, of course, is provided by WorldSim. So in a little more detail, the ride and handling model provides the motion and low frequency vibration and also feeds source strength vibration levels to the NVH model, which then combine this with transfer functions to generate vibration at the driver touch points and low frequency sound. And then the NVH model uses fills up the rest of the spectrum. So you get the higher frequency sound from the NVH model. Now, if we look at the sound and vibration side of things, CAE data and test data are sometimes combined together to get to this full spectrum simulator experience. Now, there's many different types of CAE techniques that are used to generate sound, and each is good for a specific frequency range. And none of them really cover the whole frequency range. So you can end up with gaps in the frequency range depending on the type of CAE data you have to hand when you're building these models. So oftentimes we'll use measured data as a surrogate to fill in these gaps, to make the model more real. So in this simple example here, we have some road noise, and we're using CAE data that's generated up to 200 hertz, and then we're filling in the rest with our measured test data. Now, what that looks like and sounds like is here. So in this example, first of all, we only hear the CAE generated data from 20 to 200 hertz. So it sounds pretty muddy. It doesn't sound very realistic on its own. So next we add in the surrogate data, filtered to include the data only above 200 hertz, so we're not commingling them. In this way, the sound can be presented as a complete, realistic sound. And now you just hear that upper frequency sound, and then we put them back together, and it sounds like real road noise. There's lots of different ways that this can be applied. So VI Grade takes an open approach to creating these virtual prototypes. We basically enable an everything in the loop approach. So we can have hardware in the loop, software in the loop, model in the loop, controllers in the loop, just about anything in the loop, including drivers, obviously, of course. So in conclusion, vehicle attributes like ride, handling, sound, and vibration can't be fully understood from plots and graphs and numbers that we get directly from simulations. They're valuable, all these numbers and plots and graphs, but they're not really easily understood in human terms, how a driver or a customer is going to perceive them. So we need to translate these numbers and plots and graphs into something we can feel and hear and experience. So in the past, vehicle dynamics and NVH have been developed independently, simulated independently, but these two aspects of the vehicle very much influence each other. So we need a way to combine those just like we would in a real car. With this new compact full spectrum simulator, we can do that multi-attribute simulation, combining NVH and vehicle dynamics. And now you can feel and hear and experience all aspects, adding up to the ride comfort and vehicle refinement all together in one simulator at the same time. So combining these attributes creates an incredibly immersive experience where you can make decisions quickly and with confidence. So thank you very much for your attention. And if you haven't already done so, I'd like you to invite you to experience the compact FSS that's here today, right down the hall. All right, thank you.
Thank you very much, Dave.
All right.
Steve Ponside there. All right, appreciate it. Yes, Dave's going to be afloat around for the next few hours. In fact, I think he's here till 11 p.m. He's also responsible to put the chairs away. So if you want to talk about the FSS, please feel free to track Dave down and connect with him about it. But it is a very powerful tool, and it's something that truly differentiates VI grade.